Jupiter, the largest planet in our solar system. Imagine a gas giant so massive that it could hold all the other planets together. With a diameter of about 139,822 kilometers, Jupiter is 11 times wider than Earth and over 300 times more massive. But what really makes Jupiter so special? Well, the answer lies in its fascinating features. Jupiter is not just a big planet, it is a world full of mysteries. It has a turbulent atmosphere with fierce storms and winds blowing at incredible speeds. The famous Great Red Spot, a storm larger than Earth itself, is one of the many intriguing aspects that make Jupiter so captivating. In this section, we will explore the features that make this gas giant one of the most fascinating celestial bodies in our solar system. Now that we know Jupiter is immense, let's dive deeper into its composition. Unlike Earth, which is a rocky planet, Jupiter is predominantly composed of hydrogen and helium, with a small amount of other elements. This dense atmosphere is where the storms and cloud bands you see in images occur. But what lies inside Jupiter? Beneath its thick cloud layer, it is believed that there exists a solid core of rock and metal, surrounded by a massive layer of metallic hydrogen. This unique structure not only influences the planet's gravity, but also generates an extremely powerful magnetic field, which is the strongest in the solar system. You might be wondering, why should we care about Jupiter? The answer is simple. The Juno mission, launched in 2011, was designed to unravel the secrets of this gas giant. With a set of advanced scientific instruments, Juno is providing us with valuable data about the atmosphere, magnetic field, and even the origins of Jupiter. What we learn from Jupiter can help us understand not only the formation of our solar system, but also the formation of other planetary systems around distant stars. Imagine the importance of knowing the rules of the cosmic game we live in. Each discovery about Jupiter can provide crucial clues about the history and evolution of our own planet Earth. The Great Red Spot and other storms. Now that we have explored the immensity of Jupiter, it's time to talk about one of its most iconic features, the Great Red Spot. This colossal storm is so large that it could easily swallow the entire Earth. Discovered in the 17th century, the Great Red Spot has intrigued scientists and astronomers for centuries. It is a constantly swirling storm, and its size and color change over time. But what causes this vibrant red color? Although the exact origin of the color remains a mystery, scientists believe that chemical compounds present in Jupiter's atmosphere, when exposed to the sun's ultraviolet radiation, may be responsible for this impressive coloration. In the next section, we will explore the dynamic behavior of this fascinating storm. In addition to the Great Red Spot, Jupiter is home to many other storms and weather systems. The storms in Jupiter's atmosphere are much more than just impressive visual phenomena. They play a crucial role in the planet's weather dynamics. The Coriolis forces and the planet's rapid rotation generate winds that can reach speeds of up to 640 kilometers per hour. These storms interact with each other, creating a complex pattern of jet streams and storm fronts. Moreover, the life cycle of these storms can vary greatly, with some lasting days and others lasting centuries. The study of Jupiter's storms helps us better understand not only the planet's meteorology, but also the fundamental principles governing atmospheric dynamics in general, including Earth. While the Great Red Spot is the most famous, we cannot forget to mention other storms and weather phenomena on Jupiter. Among them are the so-called white storms, which are similar to tropical storms on Earth. These systems can develop rapidly and result in bursts of impressive atmospheric activity. Jupiter's atmosphere is filled with layered clouds, with color variations ranging from white to brown and red, depending on depth and chemical composition. This phenomenon creates visible bands, which are striking features of the planet's appearance. With such a dynamic atmosphere, Jupiter continues to be a natural laboratory for understanding atmospheric phenomena on scales we cannot observe on Earth. Studying these storms is not only fascinating, but may also have implications for terrestrial meteorology. The composition and structure of Jupiter. Now that we have talked about the atmosphere and storms of Jupiter, let's delve into its internal composition. Jupiter is a gas giant, and this means its structure is quite different from that of Earth. But what really exists beneath its thick cloud layer? At the top, we find a layer of hydrogen and helium, with some molecules of ammonia, methane, and water vapor. As we descend, pressure and temperature increase significantly. That's where things get interesting. Beneath the gaseous atmosphere, Jupiter has a solid core, which is surrounded by layers of liquid and metallic hydrogen. This layered structure of hydrogen may seem strange, but it is crucial for understanding how Jupiter generates its powerful magnetic field. The core, composed mainly of rock and ice, is the key to many of the phenomena we observe on the planet's surface. Another intriguing factor about Jupiter is its incredible rotation speed. The planet takes only about 10 hours to complete one rotation around its axis. This rapid rotation has a direct impact on its atmosphere and internal structure. The centrifugal force generated by the rotation causes the planet to have a slightly flattened shape at the poles and wider at the equator. This flattening is one of the factors that affect atmospheric currents and storms. This rapid rotation also contributes to the formation of the visual features we see in the atmosphere, such as cloud bands and spiral storms. Jupiter's rotation speed generates a more pronounced Coriolis effect, resulting in stronger winds and more dynamic storms. This offers an interesting comparison with Earth, where slower rotation results in different weather patterns. Jupiter has the strongest magnetic field of all the planets in our solar system. This magnetic field is generated by the movement of metallic hydrogen within. The strength of Jupiter's magnetic field is so powerful that it extends millions of kilometers into space, creating a magnetosphere that is more than 20 times larger than Earth's. This magnetosphere not only protects Jupiter from solar and cosmic radiation, but also influences its satellites. The Galilean moons, such as Io and Europa, experience magnetic effects that affect their surfaces and atmospheres, leading to the creation of stunning auroras. Understanding Jupiter's magnetic field is fundamental for studying how the magnetosphere affects the conditions of its moons and how these interactions influence the dynamics of the solar system as a whole. The moons of Jupiter. Jupiter is not only the largest planet in the solar system, it also hosts one of the most fascinating moon systems. Jupiter's 4 largest moons, known as the Galilean moons, Io, Europa, Ganymede, and Callisto, are true worlds in themselves. Io. This moon is the most geologically active body in the solar system. Its surface is marked by hundreds of active volcanoes and lava lakes, a result of intense internal heating caused by Jupiter's gravity. What does this mean for Earth? The volcanic activity on Io can offer clues about planetary geology and processes that also occur on Earth. Europa. Europa is an ice-covered moon, and many scientists believe that beneath its icy crust lies an ocean of liquid water. This potential discovery makes Europa one of the most promising places in the search for extraterrestrial life. If life can exist on Europa, it makes us question, how rare is our planet compared to other worlds that may harbor life? Ganymede, the largest moon in the solar system, Ganymede has a thin atmosphere and its own magnetic field. This raises questions about surface conditions and whether there could be life in its inner layers. Callisto, the farthest of the 4 Galilean moons, has a surface riddled with craters and is considered one of the oldest surfaces in the solar system. Studying Callisto can help us better understand the history of our own planet. Jupiter's moons not only orbit the planet, they also interact in intriguing ways with Jupiter's atmosphere and magnetic field. This interaction generates unique phenomena such as the auroras observed on Io and Europa. The charged particles from Jupiter's magnetic field collide with the surfaces of the moons, resulting in stunning light displays. This dynamic can also affect the atmospheric composition of some of these moons. For example, Io is constantly releasing sulfur and other elements due to its volcanic activity, influencing radiation conditions and chemistry around Europa. In addition to its fascinating moons, Jupiter plays an important role in protecting Earth. Its immense gravity acts as a shield, deflecting comets and asteroids that could threaten our planet. Often, when a celestial object approaches Earth, Jupiter can alter its trajectory, reducing the likelihood of catastrophic collisions. This protective effect is one of the many factors that make Jupiter a fascinating planet. The relationship between Jupiter and Earth raises questions about how life on our planet has been shaped not only by Earth itself, but also by the influences of other celestial bodies in our solar system. The future of Jupiter exploration and its implications for life on Earth. In recent years, space missions to Jupiter have had a significant impact on our understanding of the planet and its moons. The Galileo mission, launched in 1989, was a milestone, providing valuable data about Jupiter's atmosphere and its moons. The detailed images and measurements taken by the spacecraft helped reveal the complexity of Io, Europa, and Ganymede. Currently, the Juno mission is ongoing. Since its arrival at Jupiter in 2016, Juno has been investigating the planet's composition, gravity, and magnetic field. The discoveries made by Juno may help us better understand how Jupiter formed and evolved over time, as well as explore atmospheric conditions that may ultimately have an indirect impact on Earth. The next major mission to be launched is the Europa Clipper, scheduled for the 2020s. The primary goal of the mission is to investigate the moon Europa and its characteristics, particularly the possibility of an ocean beneath its surface. The results of this mission could fundamentally change our understanding of the potential for life beyond Earth. As we study Jupiter and its moons, we must also reflect on the implications these discoveries have for life on Earth. Understanding how giant planets like Jupiter formed and evolved provides insights into our own planetary history. This knowledge can help us assess the conditions that led to the development of life on our planet and identify factors that may be crucial for the existence of life on other worlds. Furthermore, the complex interactions between celestial bodies highlight the importance of preserving our planet's environment. With growing concerns about climate change and environmental degradation on Earth, understanding our place in the solar system and how other planets influence us is more relevant than ever. In summary, Jupiter, with its fascinating features and dynamic moons, continues to be an area of significant interest for scientists and researchers. The exploration of Jupiter not only enriches our knowledge of the solar system, but also sparks questions about the potential for life beyond our planet and emphasizes the need to protect the fragile environment we call home. If you're as fascinated by these discoveries as we are, don't forget to subscribe to our channel. Join us on this journey of exploration and curiosity. Turn on notifications so you don't miss our next videos, where we'll continue exploring the mysteries of space and the incredible connection between the cosmos and life on Earth.